Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 11 Euclidean Geometry, and in this video we will be proving one of the theorems that states that the angles in the same segment are equal. In other words, the angles that we're trying to prove are equal would be S and Q. We can also prove that P is equals to R, but for the sake of simplicity, for the sake of this video, we will only be proving that S is equals to Q. So without any further ado, let's get straight into it. The first thing that you want to do when proving this theorem is you want to construct two radii. So we are constructing the radii. Notice that the angles we're given in the question are S and Q. The radii must exclude these angles. So I'm going to construct a radius OP, and then I'm also going to construct the radius OR. This is the first step in the proof of the theorem. So let's go ahead and actually construct these radii. So we want to go ahead and draw a line all the way from the center of the circle down to point P. Then we want to draw another line from the center of the circle to point R. Right. Now let's move on with the proof. By looking at what is created here, let's see if we can identify something familiar. Notice something. If we go and look at the part that I'm about to highlight, try and identify the diagram, or try and identify which theorem the diagram that I'm highlighting belongs to. And it's important for you to understand or to look at which diagrams are associated to which theorems, because this is the only way that you'll be able to identify a theorem properly and be able to solve questions in an exam. So looking at the diagram that we've highlighted here, you can clearly see that angle O, so angle O is equals to 2 times angle S. And the reason for this would be the angle at the center of a circle. We know that this is equals to 2 times the angle at the circumference of a circle. We've actually looked at this theorem previously. If you have not watched our video on the proof of the theorem as well as how to identify the theorem, please go have a look at it. I will leave a link down in the description below. Now, that's the first part. Let's actually see if there's anything else we can identify from an unknown theorem. When you look at the second part of the diagram, which I'm highlighting right now in green, let's see if we can get a darker color or perhaps a different color. Let's use red. Looking at the diagram that I'm highlighting in red right now, try and see if you can also spot a familiar theorem that we have looked at in one of the past videos. So, looking at this diagram, you could see that we also have the same theorem, that angle at the center is twice the angle at the circumference. So what I could do is I could say, but wait a second, angle O, whoops, that's the wrong color. Let's fix this. So we can also see that angle O is also equals to 2 times angle Q. For the very same reason, the angle at the center of the circle is equals to 2 times the angle at the circumference. So we've got two angles which both give us O, the value of angle O. What we can therefore do is we could say, let's equate the two angles. So 2S is equals to 2Q because the both of them give me angle O. I can divide this by 2 and divide this by 2. The 2's will cancel out. I will remain with angle S. The 2's will cancel out. I will remain with angle Q. I have proven that angle S is equals to angle Q. Brilliant. Life is great. We are done proving the theorem. I hope that this makes sense to you guys. I hope you enjoy the content and that you understand how to prove this theorem. It might not be for examinable purposes, but it's important at times for you to know how theorems are proved in the event that you'll need to do so in an assessment or in a test or perhaps just in an assignment. Please do subscribe to the channel. If you enjoy the content, please give us a like. Please subscribe to the channel, as I've said, and click on the bell icon so that you will always receive an update every time we upload new videos. Until then, enjoy the rest of the day. Ciao.